Here we have a 2007 Buick Lucerne. It has a SFI system and it has electronic returnless fuel. Here we have the wiring diagram for evac controls. In this wiring diagram we have the fuel pump fuse, the fuel pump relay, the fuel pump, the canister vent fuse, the evac emission canister vent solenoid valve, and the fuel tank pressure sensor. Here in the back seat, behind the driver's side, we have the relay and fuse box. This one right here is the fuel pump relay. Here we have the fuel pump relay, and on the relay you can see the diagram that is a 5-pin relay. 85 and 86 is to control the coil. 30 is common connector to normally open and normally close. 87 is going to be normally open, and 87A is going to be normally closed. Here we are plugged into the 85 connector with the car off, and we have a voltage of 13 volts. With the key on, 85 still has source voltage, which is 12 volts right now, and then 87A, which is normally closed, also has a voltage of 12 volts right now. Here we have the fuel pump relay driver's side to the PCM probed, and we have a test light connected to power, which will activate the relay control switch, and with touching this we can turn on the fuel pump itself. When we touch it, the light should come on.
Now in the back of the car with the fuel pump uncovered, we will do the same procedure.
Here we have the wiring diagram for the fuel injectors. As you can see, right here we have the ignition coil fuse, which goes down to each injector 1 through 6, and they are controlled by ground.
This is a diagram of the connector for the fuel injector. Pin A, which is a pink wire, is the ignition 1 voltage, and pin B is a tin with an orange stripe wire, and that is the fuel injector 1 control.
Here we have 3 of the ejectors on this side of the engine, the other 3 on the other side of the engine, and they all do have the same color wires.
Now we will disconnect one of the fuel injectors and test the resistance on it. With the ohm meter connected to the fuel injector, we're reading right around 12 ohms. So now that we've confirmed that all of our fuel injectors are in the acceptable range of resistance, we have the connector back probed. So now we can check voltage drop at idle and at higher RPM. So right here we're seeing just under a volt of voltage drop. So now we're gonna ramp up the RPM and see what the voltage drop is then. So now we're gonna disable the alternator by removing the connector wire and view how that affects voltage drop across the injector. At idle, we're a lot lower voltage drop than we were with the alternator connected. So now with the alternator re-enabled by plugging back in the connector, we can create a small vacuum leak and see how this will affect the voltage drop at idle.
Here on the scan tool, we have the ejector pulse width module in milliseconds, and at idle it's around 4.5 seconds, and with the increase of RPMs, the milliseconds go up. Here we're connected to the snap-on scan tool, and we can see fuel tank pressure, which is 0.34, and we have fuel tank pressure voltage, which is 1.4, and then we can go down to short-term and long-term fuel trim, which is right now idle. Short-term is 1 and 2%, and long-term is 5.